All right, one common way to display data, especially if it's kind of related to a frequency distribution or the distribution of data, is by using a histogram. All right, so what is a histogram? A histogram is a bar graph of a frequency or relative frequency distribution in which the height of each bar corresponds to the frequency or relative frequency of the class. Histograms are probably, I would say, one of the more frequently used types of statistical graphs. Just they're pretty easy to interpret. One difference between a histogram and a bar graph, most histograms will not have any spaces. So let me show you an example really quick. Let me pull that up in the ebook. I'm on around page 85. So if you were following along. So here is a histogram of the heart rates. Remember, we were looking at heart rates in an earlier section. And this is what the histogram of student heart rate data looks like. And so you can see here at the bottom we have the classes. And then on the side here we have the frequency. And notice there's no gap in between the bars. Alright, so, and it goes as high as the frequency from the class, of course. Just an easy way to represent data. Alright, so that's a histogram. 3.6 is on the stem and leaf display. Stem and leaf display, if you really have never heard of it, is a little confusing at first. It's just a way of writing a set of data kind of in shorthand, if you understand what that is. It's a way of writing multiple numbers just using just a couple of numbers. So it is a little bit different. let me see. The official definition really isn't in your book. It just says that it's a hybrid graphical method. But if you were to take a set of data, let me see if I can find us a set of data really quick. I can probably find one in your book. Alright, so look at this set of data here. So this is on page 87 of your ebook. Alright, so here's the set of data right here on the left. Alright, for this number, the stem is considered to be, they have 0, 9. I've seen it written just 9. This is the first time I've seen a 2-digit here in this book, but it means the same thing. 99, they have 0, 9. 108, the stem is 10. 110, the stem is 11. And 111, the stem is 11. And then the leaf is the last number. So the leaf is 7, 9, 8, 0, and 1. Now what we can do to represent this data kind of in a compact way, it's just, like I said, kind of like shorthand. It would be written like this, like 0, 9, and then on the right here, since we have 2 stems of 0, 9, we'd have 7, 9. So what that stands for is 0, 9, 7, so 97, and 0, 9, 9, so 99. Okay? And then our other stem was 10. We only had one number that went with 10, and that was the 8. So that's 108. And then the stem is 11. The leaf is 0 and 1, so that's 110 and 111. Alright, so you can see that it's just a shorthand way of writing a set of data. So if you had a really big set of data, then you could represent that in a stem and leaf graph or display pretty easily. Here is another stem and leaf set of data that's given in your book. And so this would stand for 67, 69, 68, 65, 62, 77, 79, 74, 78, and so on and so forth. Alright? And this chart was pulled out of your book around page 88, just somewhere in there. Alright. Once you understand how the data is being displayed, then it's pretty easy to figure out how to get data from that table. But like I said, if you've never seen that, then it looks really confusing. But it's actually not that confusing.